Hello everyone, my name is Tarun Murmu and I am a student in the Department of EC at Quiver Women Engineering College. Today I will be presenting on a fundamental topics in engineering. The classification is a key part of our simulation system course. What is a signal? To begin, let's establish a clear definition of what a signal is. A signal is essentially any physical phenomenon that conveys information. Think of everyday example like music, speech, or even a heartbeat. These are all signals we encounter constantly in our day-to-day life. Mathematically, a signal is a function of one or more independent variables. For instance, a simple signal could be represented as x of t equal to 0.70, which is a linear signal. Now that we know what a signal is, we can start to see how they are categorized. Signals can be classified in many ways. We can classify them based on the numbers of sources, such as one channels versus multi-channel signals. Another way is by the numbers of dependent variables, which give us one-dimensional and multi-dimensional signals. A very important classification, however, is based on whether the dependent variables is continuous or discrete. This leads us to analog and discrete signals. Let's dive deeper into that last point, starting with continuous signals. A continuous or analog signal is defined for every possible value of its independent variables. When the independent variable is time, we call it a continuous time signal. In this type of signals, both the magnitude of the signals and the independent variables are continuous. You can see this clearly in the graph where the signals is a smooth, unbroken line. In contrast to continuous signals, we have discrete signals. A discrete signal is only defined at discrete intervals of its independent variable. These are often the result of sampling and analog signals for processing by digital system. For a discrete time signal, the independent variable is represented by an integer and the signal is only defined for these integer values. As you can see in this diagram, the signal is represented by distinct vertical lines rather than a continuous curve. Now let's focus especially on continuous time signals, which can be further broken down into several sub-classifications based on their characteristics. These classifications include deterministic versus non-deterministic, periodic versus non-periodic, and even versus odd signals, which is also symmetric versus antisymmetric signals. We will also look at energy versus power signals and causal versus non-causal signals. The first sub-classifications help us understand a signal's predictability. A deterministic signal is one that can be completely described by a mathematical equation. Examples include sinusoidals and exponential signals. On the other hand, non-deterministic signals or random signals have characteristics that are unpredictable. A great example of this is the noise from electronics amplifier, periodic and non-periodic signals. A periodic signal has a pattern that repeats itself over a certain period of time. This condition is mathematically defined as x of small t plus capital T equal to x of small t. If a signal does not satisfy this condition, it is called aperiodic or non-periodic. Another important characteristic is a signal's symmetry. An event signal is symmetrical with respect to the vertical axis at t equal to 0. The condition is x of t equal to x of minus t. A classic example is a cosine signal because cos minus theta equal to cos theta. Conversely, an odd signal is anti-symmetrical with respect to t equal to 0. The condition for this is x of minus t equal to minus into x of t. The sine signal is an odd signal since sine minus t since sine minus theta equal to minus sine theta. Finally, we classify signals based on their energy and power. Energy signals have a finite constant energy but zero average power. Their energy is calculated using this integral. Conversely, power signals have finite average power but infinite energy. Their average power is defined by this equation. The key point is that for a periodic signals, the average power can be calculated over just one period. To wrap up our sub-classifications, let's talk about a signal's existence in time. A causal signal is one that is defined only for time greater than or equal to 0. This means for any time less than 0, the signal is 0. On the other hand, a non-causal signals exist for either time less than or equal to 0 or both a positive and negative time. A, a special type of non-causal signals is called an anticausal signal, which is defined only for t less than 0. In summary, we have covered the basics of signals and their classification. Signals are a way to represent information and categorized into continuous time and discrete time signals. We also show how continuous time signals can be further classified based on properties like determinism, periodicity, symmetry, and their energy and power characteristics.